Our next talk today is building a heterogeneous MPI stack with EasyBuild. Pass across to Alex now.
I have audio problems. I'm not hearing anything.
We can hear you. Okay, we'll check if Alex can. Yes. Yes, we hear you. Yeah, we'll check if Alex can sort out his sound problems.
Okay, I don't know what happened with my headphones, but they just started making weird noises. So I'll go without headphones. So shall I start?
Yes.
Okay.
Go ahead.
And well, thanks for joining me in this talk. Today, I'm going to show you how to build the MPI stack with EasyBuild automatically in a heterogeneous hardware environment. And what I'm going to show you is based on what we developed in a project that we carried out at VUB last year. And VUB is the university for the Flemish community in Brussels. And last year we migrated our university cluster to a new job scheduler, Slurm. So that implied reviewing all the MPI installations in our system and our tools to build and deploy those installations. So I'm Alex, and I work at the HPC team of VUB. Our team is an horizontal team with few people, so everybody does a little bit of everything. So my tasks consist in the common Linux sysadmin job in the university cluster. I also carry out software optimizations for the researchers of the university, as well as direct user support or hardware maintenance when needed. I'm also a maintainer of EasyBuild, which I guess that you all know very well, since we are already in day 3 of this EasyBuild user meeting. So this is our cluster, and it's a small cluster. It's a tier 2 HPC, but its complexity relies in its diversity, as it's a heterogeneous cluster, which means that we have groups of nodes with different CPU microarchitectures and different interconnects. The cluster is upgraded gradually. That means that whenever we have budget for new hardware, we buy the best cost-effective hardware at the time. So it changes over time. By the way, even though what I'm going to show you is the result of our experience with our system, due to its diversity, I think that what you will find in this talk is can be useful for most of the users of EasyBuild. Actually, our cluster is a very good representation of the average EasyBuild user based on the stats that were shown the first day of this meeting. So as you can see, we have most of our nodes are Intel Skylake nodes. We also have a few AMDs and TUs, and we also belong to that declining curve of users with old Ivy bridges. But in our defense, those will be decommissioned in the coming months. So we will push that curve even lower for next year. So as I said, we have different groups of nodes and different CPUs, different interconnects. This is presented to our users as a single cluster. So our users do not really need to know any of this. So when they submit a job, they just need to request some number of cores, amount of memory, and then the job will run. If they really want some specific hardware, they can request it. So that's always possible. And the only limitation is that jobs do not run in nodes belonging to different groups of nodes to different of these aisles that you see in the slide. So, because otherwise it becomes extremely problematic. So each group of nodes is contained from the others. So then, regarding MPI, for those that are not familiar with it, MPI is the message passing interface, which is a de facto standard that applications use to leverage the distribution of their workload and the synchronization of the different workers that are executing the simulation in multiple nodes. So basically it serves to offload out of the application all the complexity of handling the network connection. So the MPI implementation will check the hardware, will check network connections, will establish the communication. So it's a complex entity. So, and as a result, you will see that the toolchains in EasyBuild that provide MPI support are the higher level toolchains, because even if it's just one more dependency, that implies a lot. I'm not gonna go into detail on the wall structure of the MPI stack. I will describe a little bit the different parts in the stack. But for those interested, I recommend the EasyBuild Tech Talk, the ABCs of OpenMPI, which goes into much more detail of what libraries are used in a modern MPI stack. So for now, I'll start with OpenMPI, which is the main open source MPI implementation. And OpenMPI has its own runtime environment, the Orte. And Orte will do this work of checking hardware, checking network, and establishing all the communications for the application. So modern OpenMPI depends on several external libraries that actually serve to leverage this work of checking the underlying system. So you will see dependencies to check the hardware, like HardwareLock, dependencies to handle the network, like UCX and LibFabric. And this means that actually modern OpenMPI does not really touch much the metal of the system. It relies on these external libraries. So, as I said, we are concerned in our system, in our cluster, because we have different hardware configurations. So what we now have to do is check these external libraries and see how they are configured by default in EasyBuild, and how they will interact in each of our different groups of nodes with different hardware configurations. So I'll start with HardwareLock, which is just an abstraction layer that serves to check the topology of the hardware. So that means it gives information about NUMA nodes, the locality of memory banks, even the position in the bus of PCIe devices. And HardwareLock has two dependencies, libPCIe access and NUMA control. Both are handled by EasyBuild. And those two dependencies do not have any additional dependencies on other libraries. And they just interact with the kernel, basically. And the usual stuff in the system, like libc, but nothing exotic there. So installing a HardwareLock with the default easyconfigs from EasyBuild should always work in all the different hardware configurations that you can find. That's a very safe bet. On the other hand, we have all the libraries handling the network, and that's LibFabric and UCX, and things are more complex there. So both UCX and LibFabric fulfill more or less the same role. They are middleware that abstract the underlying network fabrics and hardware drivers of the network cards. And as they are configured by default in EasyBuild, you will see that both of them have an OS dependency on IB verbs. And IBverbs is the fabric of InfiniBand. And InfiniBand requires a specific hardware actually to work. So you need a specific cards, and also you need specific libraries at the system level to handle InfiniBand. And in our cluster, we have groups of nodes that do not have InfiniBand at all, that they just have an Ethernet 10 gig interconnect. So on those nodes, the system library of InfiniBand, IBverbs, might not be installed. And if it is installed, is from the CentOS repo, which is CentOS is the system that we use in our cluster. And that's actually a very old IBverbs library. So that might also give issues. And on nodes that actually have InfiniBand, that library is provided by the Mellanox offload stack, and it has a completely different version, and it's a different thing. Moreover, enabling IBverbs has also additional consequences in the MPI stack. So for instance, OpenMPI, just by being built with libfabric, will generate the libmca common OFI, which is a plugin, a shared library, that will directly link to IBverbs as well. So even though OpenMPI does not have an OS dependency in EasyBuild to libverbs, just by building it with libfabric, it will have this library directly linking to IBverbs. So that's something that we will need to pay special care to handle. Regarding the network drivers, the situation is simpler, at least for us, because we basically have the Mellanox cards in those groups of nodes with support for InfiniBand, and we only use Mellanox cards, different generations of Mellanox cards, but that is very well handled by UCX, which will auto-detect those network drivers and just offer support for them at runtime if they are available, and if they are not, they will just offer TCP. So that's something that UCX has simplified a lot compared to previous versions of OpenMPI. So then, what we want actually is to disable InfiniBand in the OpenMPI stack. So we want to compile UCX without verbs, and also remove the OS dependency, because our nodes might not have that library. And then also remove the dependency. We will also remove the dependency on libfabric in OpenMPI. And we will do this only on those groups of nodes that do not have InfiniBand, because that's the goal. On those nodes with InfiniBand in our cluster, the default configuration of OpenMPI, libfabric, and UCX provided by EasyBuild works out of the box, so that's not an issue. So how can we do this, and how can we do this programmatically and without intervention? Because we do not want to waste time going group by node to group by node and then making modifications by hand. So for that, EasyBuild provides hooks. Hooks are methods that just serve to inject code at different stages of the installation process. So you can use hooks with the --hooks option with the EV command, and then point it to some file with the code of your hooks. And then you can check also what hooks are available in your EasyBuild installation with the EV-avail hooks option. And you will see that almost all, or I guess all the steps in the installation process, like parsing the easyconfig, and the configuration step, the build step, the installation step, all of those are covered by hooks before and after the step. So what does a hook look like? So this is, for instance, a very minimal hook for the configure step. And this is the pre-configure hook, so it will run just before the configuration. And once you define the method, it's just a matter of you can write code in it, as you will do in an EasyBlock, for instance. you have all the methods of the EasyBlock available to you. And to actually modify the actual easyconfig object in EasyBuild. So for instance, in this case, what we do is we check the name of the package being installed. And that's because we run our hooks in a general manner. So every time that we do an installation in our cluster, we always attach the same library of hooks. Otherwise, it becomes an additional complexity to handle when hooks are used in the installation commands. So those run always. So then we check inside the hook what's the software being installed. And then there you can just, for instance, in this case, we update the config ops parameter of, let's say, OpenMPI, and we can add some with whatever you want to enable in that configuration parameter. And that will be done automatically. And for that you can use, so that will be done automatically whenever you install OpenMPI, an easyconfig of OpenMPI. And that means that you can use the OpenMPI easyconfig from the upstream repos in EasyBuild without having to bother in editing the easyconfig yourself. So that's very handy. So how do we use this feature in our system, and how can you use this feature in yours to, for instance, disable the verb support in UCX programmatically? So in this case, we also use the pre-configure hook in EasyBuild, and it's more or less what I show you in my minimal example before. In this case, it's just a little bit more elaborate. So what we do is first we clean up the config ops from any configuration option that could relate to verbs or RDMA. And then we do a check on the machine that it's running the installation. Because, well, for us, that is simple because we use the same machines that will execute the code for the users as the machines that build and install the software. So we can easily check that if the machine has InfiniBand support by checking some environment variable, or even checking the host name would be sufficient for us. So here, that's something that you'll have to figure out for yourself, but you can do some check. And if the machine supports InfiniBand, you can then set the option for InfiniBand. And if it doesn't, you can just disable with the options without verbs and without RDMA CM. And then the next step is just basically the result of this is added to the list of configuration options for this installation. And then you get automatically the config ops of UCX updated depending on the fabric available in your system. As I said, we also want to disable the OS dependency on libIVverbs in UCX, and also disable the dependency on libfabric on OpenMPI. And for that, we can use the Parse hook. The Parse hook is a little bit different from the pre-configure hook, as that's the hook that it's executed whenever the easyconfig is parsed. So here, the information of the easyconfig is not in the self object, but in the EC object. So pay attention to that. But you can just modify the easyconfig parameters easily as they are available as a dictionary in this method. And here, what you see highlighted in yellow is just parsing all the dependencies on OpenMPI and then removing libfabric on those nodes that do not have InfiniBand. And we do the same for UCX. We parse the OS dependencies and remove IVverbs there. IVverbs is a little bit special because in EasyBuild, you might have seen it in the easyconfigs is defined by a constant. So that's why we import the easyconfig constants, and we use that constant, which is basically a tuple of different package names for IVverbs. So then we are sure that we are removing the full OS dependency from the easyconfig. And with this hook and the one I showed you before, we already have an automatic system that can disable the support for InfiniBand in the OpenMPI stack. Then we also have one additional trick that we do in LMOD. And that's because using these hooks has the consequence that we end up with two different software installations for OpenMPI. We have some nodes with an OpenMPI installation that supports InfiniBand, and other nodes will have the exact same module of OpenMPI, UCX, without InfiniBand. And actually, that's not an issue if you use different module trees for the different groups of nodes that we have. And then if you use different software module trees, that's not an issue at all. But we use a shared module tree because otherwise there's a lot of duplication and there's a lot of waste in installing all that a full tree of software, just because a few modules like UCX and OpenMPI might be different. So to avoid that, we use a shared module tree. And in that shared module tree, what we do is we install UCX and OpenMPI with InfiniBand and without InfiniBand in the same tree. And we differentiate the InfiniBand installation with an additional version suffix, which is also injected with a hook. You can do that in the parse hook, as I showed you in a previous slide. And then what we do is with lmod, we actually dynamically swap the UCX or OpenMPI modules with InfiniBand whenever the regular OpenMPI or UCX module is loaded in a node that supports InfiniBand. So as you can see at the bottom of the slide, that's the modular C file that we use, and it basically checks one environment variable that will tell if the host system supports InfiniBand. And if that's the case, what we do is we change the version of the module being loaded to the one that supports InfiniBand. And as a general measure, what we do is we always have the versions with InfiniBand supports. That's just to avoid cluttering the results of module spider and that kind of stuff. So then this becomes something that is completely seamless to the users. The users will just see the regular UCX and OpenMPI modules loaded. And those modules will actually provide the specific support for the hardware that they are running on. So that's for the so that's for the network side. And then there's one slightly additional adaptation that we have to do. And that's not related to the support for InfiniBand, but that's for Pmix. And Pmix is also used by OpenMPI internally and can also be used as an external dependency. And Pmix is basically a shared distributed memory that processes can use to exchange data. So for instance, OpenMPI uses it to handle the communication between the Orte daemons running in each compute node. But it can also be used by the process manager. So some processes, the resource manager, sorry. So some resource managers can do also support Pmix, and that's the case for Slorm. And one thing to take to keep in mind is that Pmix needs to support the authentication mechanism set by your resource manager. So for instance, in our case, our Slorm uses libmunch for the authentication. So then Pmix needs to be compiled with support for munch. And in that case, that's something that we can also handle with hooks, because the default easyconfig for Pmix does not have the dependency of the configuration with munch, which is understandable because that's something that it's very site specific. So that's something that you will have to check, and it will vary from site to site. But then what you can do is just also use a parse hook to process the Pmix easyconfig. And in this case, we add an extra dependency on the munch devel package, which is the package that we need to build the support for munch in Pmix. And we do that in all our compute nodes. So that's not hardware dependent, but that's something that we need to do because it's something that it's a specific configuration that we need to apply. By the way, if you are interested in integrating Slurm with Pmix. I'm going to show you a lot more about this subject in the upcoming FOSDEM, where I will present more information about that in the linked talk. So on the Intel side, because there's the MPI implementation of Intel, things are simpler because, well, basically Intel MPI is distributed as a binary, so there's nothing to configure and compile. But Intel MPI still has a dependency on UCX, and that's because Intel MPI supports the Mellanox drivers through UCX. So you will need UCX to support Mellanox cards if you have those. Nonetheless, as I said, UCX is very good at automatically detecting what networks drivers are available and enabling those automatically. And at runtime, it will only show you which ones can be used. So there's nothing to do on that regard here. Also, Intel MPI bundles a fork of libfabric, which some fabric providers that are not available in the upstream projects, like the fabric for using Mellanox. But also there's nothing to do there in that regard. So all the configuration that needs to be done with Intel MPI actually can be done at runtime through environment variables. And in our case, what we want to do with Intel MPI is actually set all the configuration settings with the resource manager, so with Slurm. And that's because support for Slurm in Intel MPI changes quite widely from version to version. So what we do is basically we define some default settings that apply to older versions of Intel MPI. And so we set some variables, we set some paths to the PMI implementation of Slurm. And then we add some conditional checks on the version of the actual software package being installed of Intel MPI, that to then use more modern implementations whenever possible. So newer versions of Intel MPI support PMI2. So that's what we configure in this case for versions starting from 2019.7. By the way, spoiler alert, if you check the strings in imp info in recent Intel MPIs, you will see that there are already strings for PMIX, but they do not work yet. So this might be a change in upcoming Intel MPI versions. So finally, once we have all our settings in place, then we, in this pre-module hook, which is the hook that triggers just before the generation of the module file in EasyBuild, we can either just use the mod extravars parameter, which will inject these new environment variables in the module file, or you can also just inject snippets of code as a footer into the module file. And that's useful if you want to do something more than just blindly enable or set some environment variables and you want to do some checks. Like in this case, we check that the module is being loaded inside the environment of a job in Slurm. And then in that case is when we enabled all the different configuration settings for Intel MPI to actually work with Slurm. And that's it for Intel MPI. There's nothing else that we do to automatically configure it when we install it. And finally, there's CUDA. And CUDA also plays a role in the MPI stack, thanks to the GPU direct RDMA, which enables GPU communication through the network, and also GDR copy, which enhances the transfers of memory between the GPU and the host. So the MPI CUDA stack is also a little bit complicated. It has different parts that you have to check yourself. because there's first of all the Nvidia drivers, which are not handled at all by EasyBuild. So you will have to know what version of the Nvidia drivers you have, and also check that the CUDA that you are going to install in your system is supported by those Nvidia drivers. And then for the different CUDA versions, that's fully covered in EasyBuild. So you can just use EasyBuild to install them. And as well as the MPI support for CUDA, which is provided through the UCX CUDA package, which enables the CUDA transport in UCX. All of that is fully handled by EasyBuild and should work out of the box. There's nothing to worry about that except checking the versions with NVIDIA drivers and that kind of stuff. And then finally, there's GDR copy, which it's also installed by default with UCX CUDA in EasyBuild. But that installation will only give you the libraries of GDR copy. But to actually use it, it needs a kernel module, and that is something that you will have to manually check yourself. Nonetheless, even if you don't want support for GDR copy or have no use for it, having the libraries installed is not an issue, because those do not depend directly neither on not on CUDA, not on the NVIDIA drivers, so it's not a problem having them installed. So for CUDA, basically there's some manual check that needs to be done, but it works basically out of the box, as long as you have the required drivers installed. So that's it. That's all I wanted to show you. As I hope you've seen new methods to automatize your installations and help you in doing less manual work. For us, it's been a nice improvement, and so now we can, with a single command and a single EB command, just install any MPI stack across all the different toolchain generations that we support, which are many. We have software since 2017 installed that we still support. And in a complex hardware environment as our cluster. And we can do that and with our eyes closed now and just have more free times to go for a dream. And then we also pray that the tests that we have to check the MPI will work afterwards. We have some tests already that we run in Reframe that check that MPI works as it's intended to. But we are now working enhancing those tests and to have a more exhaustive suite of tests for MPI. And finally, thanks to Ward and Sam, which are my colleagues at the HPC team in VUB. Also, thanks to the EasyBuild community, which is an awesome place to go if you have any kind of trouble installing software. They are full of nice people that will help you. And also VUB for hosting our team and letting us play with their cluster, and VSC for financial support. And thank you for your attention.
Thank you. Kenneth already has his hand up for a question, so we'll pass him first.
Yeah, very nice talk, Alex. Thanks a lot. This from the outside, or from not being very used or going very deep into this. This is quite a mess, and I think you've done a very good way of explaining how things fit together and where to pay attention to. So thanks a lot. One thing I was wondering is there anything we can or should improve in what EasyBuild does by default? So should some of that stuff from the hooks go back into EasyBuild, or should we do things more intelligently in the OpenMPI EasyBlock, for example?
It's complicated. Yeah. So I mean, what I showed is what I think that EasyBuild is doing by default. I think it's the correct approach. So since most of the HPC clusters will have InfiniBand, I think it's okay to have it enabled by default. Also, installing the IBverbs library is not difficult. It's available in the CentOS repo for free. So having even if you don't have the hardware, it's not difficult to have it installed. And getting into the mess of checking for it on EasyBuild side, it might be very troublesome. Because, for instance, in our system, we set some environment variables that help a lot with that. But otherwise, going into really checking the hardware and checking if InfiniBand is available or not, that's a problem.
There are some ideas in that direction in Archspec, for example. So which now does CPU detection mainly. There's actually a pull request by Hugo, one of the next speakers today, who looked into how we can auto-detect, I think it's InfiniBand and Ethernet networks. And that's something that EasyBuild could leverage, for example, if we want to make things more intelligent. So it can actually auto-detect, at least on the build host, whether there's an InfiniBand network available. Of course, is the build host then a good proxy for where the software will actually be run? And yeah, you still have lots of complexities there. So maybe you really need to know the system a bit to make a good decision there.
Yeah, it's, I mean, and you could be solving problems for some users of EasyBuild, but also creating problems from others. So it's,
yeah, you have to be very careful.
Yeah,
so
very careful. Yeah.
So then does that mean we need a dedicated documentation page that basically outlines most of the things you've explained and how you can throw things in a hook, or maybe even share hook files that people can just use if they want to disable InfiniBand or want to kick out libfabric or things like this?
Yeah, that could be useful actually to have a example hooks for these tasks that might be common. And in our case, we don't have a repo for them publicly available. We use a private repo for the hooks, but we could make something that is publicly available. Yeah, that could be useful.
Yeah, we have a
and link to that from the documentation of EasyBuild that explains how to use hooks.
We have a contrib subdirectory in the framework repository where you can just dump hooks, and some people have already done that. So maybe just dumping what you have there, if there's no secrets in there, even if there's system specific stuff in there. So with a bit of documentation that says this environment variable means this on our system or something, that could already be very valuable. And indeed, we can then point there from the documentation. Okay, but it's good to hear that whatever we landed with as a default in EasyBuild makes sense in general terms, and is maybe even the best thing we could do by default.
Yeah, I think so. Yeah, I think that the defaults are the best option. Yeah.
Okay. See, Bart has a question as well. We'll let him unmute. See if that works. Yep.
Yes, just a little comment. I mean, this whole talk rings a lot of bells with me. Actually, in Compute Canada, we have a single OpenMPI software installation that works on a lot of different fabrics, InfiniBand, Ethernet, and OmniPath. But the way we do it is using environment variables also for OpenMPI, which makes it in a sense more similar to Alex's Intel MPI configuration, because you use environment variables for Intel MPI, but two different modules for OpenMPI. You could in fact use environment variables for OpenMPI as well. I can share our setup in Slack as well, because it basically also use a mod Lua footer in the easyconfig, and then includes a central file with environment variable configuration, so we can sort of maintain that on the fly. And the one thing I was wondering, in your OpenMPI setup, if you have two different modules for two different hardwares, you need to use LD library path, right? You cannot use rpath in that case.
The paths do not change.
The paths do not change.
Because we use a shared software tree.
Okay.
So all the software it's in the same paths. except for OpenMPI and UCX.
Yeah.
But those, I mean, either the RPath points to the actual thing that we want to use because that's set at build time, and then the version suffix is defined there, which is part of the path, and then it's found. Or otherwise, when we sub the modules with Elmot, the only paths available in LD library path are those of the module loaded. So those are the only accessible libraries through the environment. Does
it then mean you have two Chromex versions, for instance, one for IB and one for Ethernet?
Two versions of what?
Of a higher level program like Chromex? Or
no. There's only one. No, only one.
Okay, so the libmpi.so is in the same location, so they're mounted different file systems. Is that how you do it?
No, so the libmpi, there are two libmpi, which are in different folders, one with the version suffix and one without the version suffix.
Right. But with our path.
When using our path, this will not work.
Yeah. Something like that.
Work.
That will not work. Yeah.
Okay.
That will not work.
You could probably hack it with LD preload if you want to risk that.
Yeah.
Something like that. Yeah.
I know. Okay. That is just a major difference because we use our path everywhere.
Okay. Yeah.
So.
But we don't use our path.
Use the environment variables.
Yeah. We don't use our path specifically, so we rely a lot in the environment.
Right. Thanks. I'll put some info in the Slack. I'll do it just as
an sure. Thank you.
Question about your Ethernet. So I guess none of your Ethernet cards actually support verbs, because some Ethernet cards do. On Lumi, we actually run libfabric OFI RxM over verbs as a provider.
Yeah, that's not the case for us. Yeah, our Ethernet cards only use.
But I know some Intel 700 series cards do, but probably not all.
Yeah. Yeah, and there's also the option to use TCP over InfiniBand, which is also something else.
Yeah, but that's slow. Okay, thanks.
And another question which I was already planning to ask until you showed your last slide. So the reframe tests that you have, you say they're now relatively basic. So basically checking, I guess, stuff like MPI world, MPI hello world, or maybe OZU benchmarks, or rather minimal.
Yeah, exactly.
Things,
so what we do now is basically use OZU micro benchmarks to do a latency test and a bandwidth test between two pairs of nodes. So yeah, then for instance, we had the issue, and we had sometimes MPI applications failed. And we found out that the issue was just related to a few nodes, like 4 nodes, I think, in total that we have. And applications, MPI applications were failing on those nodes because they have actually connect X5 Mellanox cards. And the rest of the nodes in that node group, because all of those nodes have Intel Skylake CPUs with InfiniBand, have connect X4 cards. And we set the UCX transport in those InfiniBand nodes to the DC transport, which is a transport specific to Mellanox cards. So there's in InfiniBand there's RC for that, it's kind of an analog to TCP, and then UD for which is an analog to UDP, and then there's DC, which is something specific for Mellanox. And actually, you cannot use DC between different generations of Mellanox cards. And that completely passed through our tests. Because we test with also between pairs of nodes, but those pairs of nodes usually are chosen at random, and we don't do all the pairs in the group of nodes. So yeah, we want to enhance our test because those kinds of errors can still go through.
But that's essentially a problem in your hardware setup, not really a software thing that you could fix.
Yeah. I mean, you can. So that the workaround is to not use DC and use RC, but we want to use DC because we use Pmix with Slurm, and that allows to use the direct connect of Slurm through InfiniBand, which is something that I will explain in detail in my talk in FOSDEM in 2 weeks. So yeah, in this case, actually the solution was to just block these 4 nodes to be shared in the same pool of nodes in any job being executed in those Skylake. So yeah, it's a problem on the hardware setup, but yeah, our tests should tell us if this is an issue.
And then do you already have some tests, or are you planning tests that are checking the Slurm integration for MPI? I'm not sure if or how you would do that with Reframe. So I guess you're letting Reframe submit those jobs, and then you're running MPI in those jobs. But could you also use Reframe to test the Slurm integration?
Yeah,
would that work? I guess you could tell Reframe to run certain tests locally, and then you would do the Slurm stuff yourself in that test. That could maybe work. I'm not sure.
Actually, the thing, the thing is that there's not anything has to be checked from within the MPI environment. So you actually need to execute something with MPI to actually know if Slurm is gonna play well with your settings.
But you could let Reframe run a script that runs in the Slurm environment that you control yourself. So you have a Reframe test that does an srun that runs a script, and then the script checks its own environment or something like that.
Yeah, but we want to submit that as a job to the compute nodes.
Yeah. Okay. Well, and yeah, that will make it a lot.
Or said in other words, we want to execute that test in the compute nodes.
Yeah.
So it's simpler to go through the scheduler, but yeah, it's just a matter of defining the test and then execute it in the compute nodes.
Mm-hmm.
And for instance, one thing that can be done is to actually, because it's complicated. Yeah, because if you want to change, the problem now with our setup in Slurm is that it hard codes the UCX transport layer, and that's done in the task product of Slurm. So changing that in the tests is not trivial. So in our current setup, the only option or the easy option is to just test the actual configuration that you have deployed and not change any of that.
Do you think there's room for like a central set of tests that verify MPI somehow? So you're working,
that could be.
And we're discussing that within the VSC as well, and that's definitely a work in progress, which we haven't made a lot of progress on up until now, but it's let's say in the works. But maybe that could grow into something that's useful more widely as well. So just a small repository, focused repository that verifies your MPI setup if you're using EasyBuild. Since at least then we know enough probably about the environment that we could check specific things.
Yeah, absolutely. Yeah. And actually, I think that it should not be difficult to come to with a suite of tests that can be directly executed in a variety of clusters.
Yeah, either it works or it doesn't. You
exactly.
don't really rely on specific hardware or
yeah. So for instance, if you execute the awesome micro benchmark, it has to work. There's no configuration or anything that you should change to make it work.
And you could even probably come up with reasonable thresholds for things like latency and bandwidth, or make that very easy to configure. So people just have to say, I have this generation of hardware, or I expect 5 microseconds or something like this. And if it's way higher than 5, then please tell me because something's wrong.
Absolutely. Yeah.
Okay. Any other questions? There's a bit of discussion in the Slack to follow up on, I think. If there's no more questions, we should wrap up, Simon.
Yes, we'll wrap up there. Thanks to Alex for the
Thank you. Thank you all.